Hi all, welcome to the session on line drawing algorithm in computer graphics. Before we dive into the actual algorithm, let's understand why we even need line drawing algorithm in the first place. In mathematics, a line can be defined using an equation like y equal to mx plus c, and it can be infinitely precise. But in computer graphics, the things are different. We are working on a screen that is made up of grid of a tiny square called pixels. So we work on a tiny pixel called, tiny grid of pixels. Each pixel is a discrete unit. It's either turned on or off. So when we want to draw a straight line between 2 points, we can't draw it exactly as map. Instead, we have to approximate the line by selecting which pixel to light up so that the result look like a straight line. This process of choosing the right set of pixels is what we call a line rasterization, and it is achieved using the line drawing algorithm. These algorithms are very important in low-level graphics programming because they form the basics of how we draw a shapes, borders, outlines, and more on any digital display. In this video, we will cover two key drawing algorithms. One is DDA algorithm, which is Digital Differential Analyzer, and Resonance Line Drawing algorithm, known for its efficiency and use in real hardware. So let's get started with the first one, DDA algorithm. So as I mentioned, the DDA algorithm is nothing but a digital differential analyzer. So this particular algorithm, it comes under the scan conversion line algorithm. So what do you mean by scan conversion line algorithm means? Imagine you want to draw a straight line on a computer screen. But here's the thing. A computer screen is made up of a tiny square boxes called pixels like tiles on the floor. You can't draw a perfect diagonal line like on the paper. You can only turn on certain pixels to make it look like a straight line. What does this scan algorithm, conversion line algorithm do? It helps the computer decide which pixels to light up so that it looks like a straight line between 2 points. Think of it like this. Like you're standing on a tiled floor. So each tile floor, you just imagine it as a pixel. You want to go from one tile, which is a starting point, to another in a straight line, that is to the end point. But you can only step on the whole tile and not in between. So the algorithm tells you which tiles to step on so that your path will make a straight line. So this is your scan conversion line algorithm. And another important thing is in DD algorithm is fully based on calculating either delta x or delta y. The Cartesian slope intercept equation for the straight line is y equal to mx plus c, where m is nothing but the slope. So this is how we are going to calculate the slope value, y2 minus y1 by x2 minus x1. So here I'm going to draw, this is going to be a starting point, this one is going to be my end point. So starting point is x1 comma y1 and end point is x2 comma y2. So from this I'm going to calculate the slope, y2 minus y1 divided by x2 minus x1. We have to find the discrete point in between x1 y1, that is, in order, this one is going to be a starting point and this one is going to be an end point. So in order to draw a straight line, we should find these intermediate points. So this intermediate point is known as the discrete points. So we have to find the discrete points in between x1 comma y1 and x2 comma y2. Consider if 2 points are xk comma yk plus 1 comma yk plus 1. So this xk comma yk is going to be my starting point, and this xk plus 1 comma yk plus 1 is going to be the next discrete point. So this particular point is xk plus 1 comma yk plus 1. So this is my starting point xk comma yk. So here I have mentioned. So consider starting point to be xk, comma yk, and the discrete point, that is the next point to be xk plus 1, comma yk plus 1. So in order to find the discrete points, we consider three cases. What are the three cases is, the case 1 is if my slope is less than 1. So if my slope is less than 1, so how I am going to find the next discrete points? So if my slope is less than 1, so this particular x value, so the x value moves in the unit interval, that is xk plus 1 is going to be xk plus 1. So I'm going to move in the x moves in the unit intervals. So then I'm going to find the value for yk plus 1. So how I'm going to find the value for yk plus 1 is, just I'm going to substitute in the slope equation. So what is the slope equation here? M is equal to yk plus 1 minus yk x divided by xk plus 1 minus xk. So I'm going to substitute this xk plus 1 and yk plus 1 in this slope equation. So yk plus 1 is the value we are going to find out, divided by xk plus 1. So in place of xk plus 1, I'm going to substitute this xk plus 1 minus xk, so that xk get cancelled. So your next discrete point is going to be, that is the next coordinate point is going to be yk plus 1 is equal to yk plus m. So the next coordinate value will be xk plus 1 and yk plus 1 will be xk plus 1, which I'm going to move in the unit intervals, and the value for yk plus 1 is going to be yk plus m. So this is how I will find the next coordinate position for the slope m less than 1. The second case. So what is the second case is, if my slope is greater than 1. So if my slope is greater than 1, then the y will move in the unit interval. The y will move in the unit interval. Then yk plus 1 will become yk plus 1. So I'm going to find the xk plus 1. The same thing, you're going to substitute this xk plus 1 and yk plus 1 in the slope equation. So we know that yk plus 1 is yk plus 1. So I'm going to substitute yk plus 1 in place of yk plus 1 minus yk divided by xk plus 1 minus xk. So you're going to cancel all those, this yk and minus yk. So you'll be getting xk plus 1 to be xk plus 1 by m. So the next coordinate position, that is xk plus 1 comma yk plus 1 will be xk plus 1 by m comma yk plus 1. So the next is case 3. Case 3 is m is equal to 1. If my slope is equal to 1, then both x and y will move in the unit interval. So that is xk plus 1 is equal to xk plus 1, yk plus 1 is equal to yk plus 1. So the next coordinate position will be xk plus 1 comma yk plus 1. So this is how we are going to find the find the next coordinate position in case of m less than 1, m greater than 1, and m is equal to 1. So consider we have find the slope, right? For positive slope coordinate value, if my slope is less than or equal to 1, then yk plus 1 will be yk plus m, and slope is greater than 1, then xk plus 1 will be xk plus 1 by m. So if this line is processed from left to right, if my line processed from left to right, for the positive slope coordinate, this will be my next coordinate position. For the negative slope, if the line is processed from left to right, then the next coordinate values will be this thing. So from the previously calculated slope, we can easily find out the value. Similarly, if the line is processed from right to left, the positive slope coordinate will be this yk plus 1 equal to yk minus m, and xk plus 1 is equal to xk minus 1 by m. And if the line is processed from right to left, for the slope, for the negative slope will be yk plus 1 is equal to yk minus m, and xk plus 1 is equal to xk plus 1 by m. So from the above thing, we have formulated the algorithm. So this is going to be the DDA algorithm. So which is in your textbook. So this initially we are going to initialize all the variables. So this dx, dy. So dx and dy is nothing but your delta x and delta y, where you'll be seeing one problem, example problem. Steps is number of increment you are going to take. How many within how many increment you are going to get a straight line. So I have initialized all the variables x increment, y increment, x, y and thing. So initially you are going to calculate delta x and delta y value, and next in order to find the steps you are going to take the absolute value of dx as greater than absolute value of dy. If the absolute value of dx is greater than absolute value of dy, then the steps is nothing but number of increments. Okay, steps is equal to absolute value of dx, else the steps is equal to absolute value of dy. So this is your algorithm. So another important thing is here you're going to round off the value. So you're going to round the value what you're getting. So we'll see an example problem so that you'll be having a clear view. Okay, so here in the question they have given the starting and end point. The starting point is 2 comma 2 and the end point is 10 comma 3. So that is you're going to draw on a straight line. So what they have given is the start point is 2 comma 2 and the end point is going to be 10 comma 3. So in order to draw this straight line, you're going to find the intermediate values. You need to find these intermediate values, right? So for that, you're going to find the steps. So what is the first thing? So they have given the starting point and end point. What is first step you're going to do? So from the algorithm, you can see you're going to find the value for dx and dy, which is nothing but delta x and delta y. So this is the first step. So they have given the question. So we're going to find the dx value and dy value. So dx is nothing but x2 minus x1. So consider this to be x1 comma y1. This one is x2 comma y2. So first one is x2 minus x1. x2 is 10 minus 2 and next is y2. y2 is 3 minus 2. So 8. So you're going to find whether the absolute value of dx is greater than dy. So the absolute value of dx is, for dx value is 8, which is greater than 1. So my steps is going to be 8. So step is equal to 8 means you're going to in between these two straight lines in the 8th step, that is in the 8th increment, you'll be getting the endpoint. So if you get the endpoint in the 8th increment, then your answer is correct. Okay, so what is the next step you're going to find? You have find the, like initially you find dx and dy you calculated. Next you calculated the value for steps, which is nothing but the increment value. So at the iteration steps, okay, this is nothing but iteration steps. At 8th iteration you will be getting the output. And next is you're going to find the x increment and y increment. So x increment formula is, I'm sorry, like steps is nothing but the iteration, number of iterations. At the 8th iteration, you will be getting the output. And x increment is dx divided by steps. Dx value is 8 and the step value is 8. So the x increment is going to be 1, and similarly, you are going to calculate the value for y increment, which is 1 by 8. Okay. What is the first point? We know that the first point is given in the question, that is 2 comma 2. So you are going to consider 2 comma 2 to be the first point. And next is you are going to set the pixel. So as I said in the screen, you are going to display the line, right? For displaying each point will be considered as a pixel. So you are going to round off these two values. So the initial position is going to be 2 comma 2. So 2 comma 2 in the sense consider this to be 0, 1, 2. So, I'm sorry, 1, 2. No? We are going to draw a pixel over here. Okay, 2 comma 2. So for the first iteration, k is equal to 1. So here they have given the formula. So for k equal to 1 to steps, that is steps value here is going to be 8. So from 1 to 8, begin x is equal to x plus x increment, y equal to y plus y increment, and next step is you're going to set the pixel. So x is equal to x plus x increment. X value is 2. That is your starting point. 2 plus x increment value we got is 1. So 2 plus 1 is equal to 3. And next is y. Y equal to y plus y increment. The value for y is 2 plus y increment. The value for y increment is 1 by 8. So while calculating, you will be getting 2.125. So what we are going to do in DD algorithm is you're going to round off the value. You're going to round off the value. So the value of x is going to be 3 and 2.125 is nothing but you're going to round the value and you're going to make it as 2. The next step is you're going to set the pixel. You're going to set the pixel. So 3 comma 2 comma 1. And next is k is equal to 2. So again, you're going, so you have find this value. So the value for this particular point is going to be 3 comma 2. The value for this particular point we found to be 3 comma 2. So next is x plus x increment. So from this you're going to continue. The value for x is going to be 3. So what we got here, 3 plus 1. Value for x increment is 1 equal to 4. And the value for y increment y is 2. Like we are not going to consider the round off value for this particular thing. You should make sure that you should consider only this decimal part. Okay, so while calculating the next discrete point, you are not going to consider the round off value because this particular rounding off is for setting the pixel. So for calculating the next discrete point, you are not going to consider this round off value. Instead, you are going to make use of this particular point. So y plus y increment 2.125 what we got here plus 1 by 8 is y increment. Y plus y increment. Y value is 2.125 plus y increment value is 1 by 8. So 2.25. Again you are going to you are going to round off the value. So 2.25. Next is again you're going to calculate the value for k equal to 3. So 4, the value for x is going to be 4, x increment is 1. So you're getting 5 and value for y is y plus y increment. The y we got 2.25 plus y increment value is 1 by 8. So you're getting 2.35. So 5 comma rounding of this 2.3 and 5 you're getting 2. So next value will be 5 comma 2. Next is k equal to 4. For k equal to 4, again you're going to calculate. So you can see, we know the value for step is equal to 8, right? So you can see at the eighth iteration, that is for k equal to 8, you're going to calculate x is equal to x value, you're getting it as 9 plus x increment value is 1, you're getting 10. Y is equal to, you're getting value to be 2.875 plus 1 by 8, you're getting 3. So at the 8th iteration, you're getting the value to be 10 comma 3, which is your endpoint. Which is your endpoint 10 comma 3 starting at 2 comma 2 at the 8th iteration. So in steps you're getting 8. At the 8th iteration, you're getting the endpoint 10 comma 3. So after plotting, you can see so this is 2 comma 2 and this one is 10 comma 3. So you're not getting the straight line. So why we are not getting a straight line is that you are rounding off the value. You are not taking the whole numbers. So you are rounding off the value for setting up the pixel. So since the fraction part cannot be considered as a pixel, we are rounding off the value. So that is the reason we are getting this jaggies. So jaggies are nothing but the staircase effect. So while zooming the screen, you can see if you are plotting something, you can see the jaggeds. So this is one of the main disadvantage of using the DDA algorithm. So one of the main advantages, it is a faster method for calculating the pixel position. But the disadvantage is rounding operations. Since you are rounding up those values, it is time consuming, and another thing is you are getting this jaggeds. So this is one of the greatest disadvantage of this DDA algorithm. In order to overcome this particular disadvantage, we are going for this resonance line drawing algorithm. So you can try for this particular question. So this is an example, another example for area algorithm where my starting point is 2 comma minus 2 and the end point is 3 comma minus 10. So you are going to calculate from the algorithm. You are going to calculate dx and dy value, and next step is you are going to calculate the steps, and the steps I'm getting it to be 8. So you're going to take the absolute value. So absolute value is nothing but if I'm considering absolute value of minus 1 means it will consider only the positive value and not the negative value. So if I'm getting absolute value of minus 1, then the answer will be 1 only. Okay, and from this question, I'm going to calculate the steps, that is number of iterations you're calculating to be 8. And next is you're going to find the x increment and y increment value. So you're going to you're going to find the discrete points. So from k equal to 1 to 8. So the starting point is 2 comma minus 3, and the end point at the eighth iteration you're getting to be 3 comma minus 10. So this is how you'll be plotting the output. So here also you can see the jaggeds, that is a staircase effect. Okay, so this staircase effect is mainly due to the rounding operations. So the second algorithm is resonance line drawing algorithm. So we have seen the DDA line drawing algorithm. So the main disadvantage is rounding of the value. So hence you are getting those jaggeds. So to overcome that particular drawback, we are going for this Bressenham's line drawing algorithm. So this particular line drawing algorithm is accurate and efficient raster line generating algorithm, and it uses only the integer increments. So here we are not going to take or consider any fractional part. We are going to consider only the integer increments, and here the vertical axis show the scan line. So the vertical axis shows the scan line and horizontal axis shows the pixel columns. The next pixel position is determined by testing the sign of the integer parameter, whether it is a positive or negative. So depending upon that particular parameter, you're going to find the next pixel position. So here also to find the discrete points between x1 comma y1 and x2 comma y2, like consider 2 points again. So here also we are going to find the discrete points. So initially we are going to take the slope. M is equal to yk plus 1 minus yk divided by xk plus 1 minus xk. So again, to find the discrete points, we are going to consider three cases as in DDA algorithm. So case 1 is m, if my slope is less than 1. So if my slope is less than 1, how I am going to calculate the next discrete point? So we all know the equation of a straight line is y equal to mx plus c. So in place of this x, so we have seen in the DDA algorithm, if my slope is less than 1, the x will move in the unit intervals, right? So we saw it in the DDA algorithm. If my slope is less than 1, the x it moves in the unit interval. So unit interval in the sense xk plus 1 will be xk plus 1. In place of x, you're going to substitute that xk plus 1 plus c. So you can see this is how the scan line will be. So this one is xk plus 1, yk plus 1. Since this xk plus 1, yk plus 1 point lies in between yk plus 1 and yk. So here you can see, okay. So the discrete point lies in between yk plus 1 and yk. We have to decide which pixel to choose, either the lower pixel or the upper pixel. So in order to identify, we are going for this decision parameter. So you can see, so you are going to plot the pixel over here. So this particular discrete point, it lies between yk plus 1 and yk. So you are going to choose whether the upper pixel or lower pixel. For this, you are going for this decision parameter. So the formula for decision parameter will be delta x. Why we are considering this delta x is, since our slope is less than 1, I am going to consider this delta x. Delta x into d1 minus d2. So this d1, d2 is nothing but a like decision parameter what I am going to choose. So from this diagram, you can see the value for D1. D1 is y minus yk. Y minus yk. So in place of y, I'm going to substitute this particular formula m into xk plus 1 plus c minus yk. You're going to substitute in the equation 1. And next, coming to D2. So D2, where it is located, yk plus 1. How I'm going to calculate this D2 is yk plus 1 minus yk. So this particular point, yk plus 1 minus y. So in place of y, again I'm going to substitute the m into xk plus 1 minus c. So I'm going to calculate. So we know the value for D1 and we know the value for D2. So we should find this decision parameter, right? So d1 minus d2. So for d1 minus d2, I am getting this particular equation. And next, the decision parameter will be delta x into d1 minus d2. So I am going to multiply by delta x. So after multiplying with the delta x, I will be getting this decision parameter pk to be this particular equation, and this equation is have marked as equation 2. Okay, so the next step is to find the next decision parameter. So the next decision parameter will be, so the initial parameter will be pk. So the next decision parameter will be pk plus 1. Okay, so in the equation 2, I'm going to substitute k plus 1 in pk equation. So wherever you have this k, you're going to substitute it with the k plus 1. So wherever I'm going to have this k, I'm going to substitute with the k plus 1. So in this way, I'm going to find the next decision parameter. For finding the next decision parameter, this is the formula pk plus 1 minus pk. We know the pk plus 1 and we know pk. So I'm going to subtract these two and I'm going to get this pk plus 1. So this will be my equation 3. And next is to find the initial decision parameter. So we know that the initial point will be xk comma yk. So the initial decision parameter will be from equation 2. So from equation 2 is pk. So since y equal to mx plus c, the c value will be y minus mx. So you're going to substitute this thing and you'll be getting the value pk equal to 2 delta y minus delta x. So we'll be getting this equation. You're going to replace x and y with xk comma yk since it is the initial point. So after replacing this x and y with xk comma yk, you're getting the initial decision parameter pk. So from the above derivation, we can summarize if my decision parameter is greater than or equal to 0, then my xk plus 1, that is the next discrete point will be xk plus 1 comma yk plus 1. If my decision parameter is less than 0, then my the next discrete point, that is next coordinate point, will be xk plus 1 comma yk. So this is about your case 1 if my slope is less than 1. And what about case 2 and case 3? Case 2 is if my m is greater than, if my 1 m is greater than 1, then y, it will move in the unit interval and you're going to find this xk plus 1, right? So what you're going to do is simply you're going to change the x and y coordinate. That's it. Simply you're going to change the x and y coordinate. So you can see in case 1, what is the initial parameter pk value? Pk value will be 2 delta y minus delta x. So see here, I have simply interchanged the x and y coordinate. That's it. So you are going to find the next decision parameter value using the previous one. And case 3 is m equal to 1. So in case of m equal to 1, both the x and y moves in the unit intervals. So this is the resonance line drawing algorithm. So this particular line drawing algorithm is for if my slope is less than 1. So we have seen how I have derived the next decision parameter, how I have find out the decision parameter, initial decision parameter. So this particular algorithm is the summarization of the above. Okay. So given the two endpoints, x naught and y naught, that I'm going to store the left endpoint in x naught comma y naught. And next step is I'm going to load this particular initial point into the frame buffer. That is, I'm going to plot the first point. And next step is I'm going to find the decision parameter. For that, I need to know the initial decision parameter. So which I am going to mention it as P naught is equal to 2 del y minus del x. And the next step is you're going to find the next decision parameter. So the next decision parameter, if my decision parameter is less than 0, then this is the formula. If my decision parameter is greater than 0, then this is going to be the formula. So you're going to repeat this step 4 until delta x times. So this is the algorithm for the resonance line drawing algorithm. So let's see with an example problem. So they have given the line endpoint. So the starting point is going to be 20 comma 10 and the end point is going to be 30 comma 18. Okay, so what is the next step? You're going to find the slope. Okay, so with the slope only you're going to decide. If my slope is less than 1, then you're going to go with this algorithm. So if my slope is greater than 1, then you're going to interchange the x and y coordinates. Okay, so what I have mentioned here is for slope less than 1. If my slope is greater than 1, you're going to interchange this x and y coordinate. Okay, so for that purpose, if the question is given to you, your first step is you're going to find the slope. So my slope is less than 1, then I'm going to go with this particular algorithm. So what's the next step? I'm going to find the delta x value, delta y, 2 delta y, 2 delta y minus 2 delta x to be minus 4. Okay. So the initial point, that is x naught comma y naught, is going to be 20 comma 10. Okay. So this is the decision parameter. So that is the initial step, and this one is going to be the decision parameter. Okay. Next is this particular thing is your discrete points. It is intermediate point xk plus 1 comma yk plus 1. So initially the k value is going to be 0 and you should find the initial decision parameter. So what is the formula for calculating the initial decision parameter? P naught is equal to 2 del y minus del x. So 2 del y is 16 minus 10, which is 6. So my initial decision parameter is going to be 6. My initial decision parameter is greater than 0. My initial decision parameter is going to be greater than 0. If my initial decision parameter is greater than 0, the next step is the x will be incremented by 1 and y will be incremented by 1. So it is greater than 0. So initial point is 20 comma 10. So both are incremented by 1, 21 comma 11. So what is the next step? What is the next step? After calculating the next decision point, I should go for the next decision parameter. Calculating the next decision parameter. The next decision parameter is pk plus 2 del y minus 2 del x. So this is the formula for calculating the next decision parameter. So p naught value, if my the p naught value is greater than 0, so I'm getting 6. So I'm going to increment 21 comma 11, and next decision parameter is p1. So this is the formula. So calculating P1, I'm getting it as 2. Again, my value for Pk is greater than 0. So I'm going to increment both x and y value by 1, 22 and 12. Okay, so again I'm going with this same formula. Since my P1 value is greater than 0, so I'm going to calculate the next decision parameter using this particular formula. So by calculating the next decision parameter, I'm getting it as minus 2. Minus 2. If my pk value is less than 0, then I'm going to increment. See, if my pk value is less than 0, I'm going to increment the x value by 1 and keeping the y value as such. If my pk value is less than 0, I'm going to increment x value by 1 and keeping the y value as such. So I'm getting it as minus 2, which is less than 0. I'm going to increment the x value from 22. It is incremented to 23, and I'm going to keep this y value as such, 12, 12. Y value, I'm going to keep it as such. Okay. So again, for calculating the next parameter, decision parameter, what is the formula for calculating? So I have calculated pk value is less than 0, that is minus 2. For the next decision parameter, I'm going to go with this particular formula. Pk plus 1 is equal to pk plus 2 delta y. So by calculating, you'll be getting value to be 14, 14 which is greater than 0. So I'm going to increment both x value and the y value. Similarly, this process will continue. So in the algorithm, you can see you're going to repeat this step 4 until delta x time. What is the value for delta x? 10. So at the 10th iteration, so starting from 0 to 9, that is at the 10th iteration, you will be getting the endpoint. If I am getting the, what is the endpoint here? 30, comma 18. So at the del x times, at the 10th iteration, you should get this endpoint. If you are getting this endpoint, it means that your answer is correct. You can see. So you can see somewhat straight line. When compared to DD algorithm, you will be getting a somewhat straight line in the dissonance line drawing algorithm. I hope you understand this line drawing algorithm. Thank you.